Today our lesson is on 11.8 in your notes, and it's called expected value. And so today we're going to learn how to compute the expected value. And I really wanted to kind of give you a little bit of an idea of where we would use this. And this is kind of the intro for, when we look at insurance companies and they try and look at rates and determine whether or not, like how to establish a rate, an insurance rate, they'll look at kind of the expected value to help to calculate your insurance rate. Also, casino companies are going to be looking at the odds of things like to make sure that the expected value would be something that the casino, because again, where your odds of going to somewhere, you're going to pay out to maybe bid or gamble on something, and casinos are going to want you to win some, but they're also going to want to make sure that they turn a profit. So that's kind of where you're going to see some application for this kind of this term. So to compute the expected value. So to define it, expected value is a mathematical way of using probability to determine what to expect in various situations over the long run. And what we're going to find is we're going to determine that we're going to use it for insurance companies, business alternatives. We're going to have an example of that, and then also maybe from chance. And to find the expected value, what we will do is we will multiply the expected value times the probability. So first of all, we're going to look for the expected value for the number of girls for a family of 3 children. Now remember, we talked about that with probability, and if I had 3 different children, then I know the probability of getting a girl would be 1 out of 2. The second one would be 1 out of 2, and the third one would be 1 out of 2. And so we've already calculated that probability, and that would be 1 out of 2 times 2 times 2, or 1 out of 8. And so keep in mind, we've done a problem similar to this in our other units, but I kind of wanted to show you a little kind of how that came out. And so I just went ahead and get a chart of orders of kids. So in other words, if we had a boy, 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 obviously we have 0 girls. And the probability, we have a total, if I go through and I change it with 1 girl, I have a girl, boy, boy, I have a boy, girl, boy, or boy, girl, boy, and I have boy, boy, girl. I'd also have girl, girl, boy. With 2 girls, I have girl, boy, girl, I have boy, girl, girl, and then I would have the combination of which would be girl, 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 girl. I have a total 1, 2, 3, 4, 5, 6, 7, 8 different outcomes that I could have. And then so the probability of getting all would be then 8, because one combination of getting 0 girls. Then if I have 1 girl, we notice I have 3 different possibilities in my combination. So the probability of getting just 1 girl would be then 3/8. The probability of getting 2 girls then would be then 3/8 as well. And then I've got the probability of getting 3 girls would be then 1/8. And to calculate this expected value, what we're going to do is we're going to multiply each of our terms. So if I have 0 girls, I'm going to multiply it times my probability of 1/8. Then I'll have 1 girl times my probability of 3/8, plus my probability of 2 girls would end up being then 3/8 as well. And then my last one with 3 girls, I would have 3 girls, and then my probability would be back to 1/8. And then on this one, I would go ahead and just simplify it. And so again, 0 times that's just 0. And then so I end up with, I know I'm kind of coming into this is my I have 3/8 plus then 6/8 plus then 3/8 again. And then I would just go ahead and add my fractions together. So 3 plus 3 is 6, plus 6 is going to be 12, so I'd have 12 over 8. And my expected value then would be the simplification of that. So in other words, I could divide both sides by 4. And so in this case, I'd have 3 out of 2, or 1 1/2, or 1.5. So my expected value for having for the number of girls of 3 would be 1.5. Then I'm going to look at an example for insurance premiums. Bill Insurance Company has determined the probabilities of various claims amounts to the nearest 2,000 for drivers 16 through 21 as shown in the table. And so they've already given us the a table. So in other words, those students that would have a $0 claim accounts for 70%, or the probability would be 70%. 2,000, 15%, and so on and so forth down. So the expected value would mean that we would start off with the amount claimed times the percent. So 0 times 70 plus I'd have 2,000 times 0.15, which is that, and then 4,000 times 0.08, 0.08 if I want 0.15, plus 6,000 times 0.05. I'm going to continue it on as 8,000 times 0.01, and then the last plus 10,000 times 0.01. And then when we add these amounts together, I'm just going to go ahead and cheat real quick because I already calculated before. But that means that when you add this up, you will end up with $1,100. And so what that means is that in the long run, the average claim is going to be then $1,100, and which is very least. In other words, the company, if they're going to charge drivers between the ages of 16 and 20, the minimum they should charge would be $1,100 for that claim. And that just kind of tells you what they would have to do to break even. The next one is an architect. So an architect is considering bidding for a new design of a new museum. The cost of drawing the plans and submitting a model is going to be $14,000. The probability of being awarded the bid would be 0.2. If the architect was awarded the bid, she will make then $70,000. But remember, it's going to be minus the $14,000 of the original cost for the plans of the model. So let's think about it. If we're going to look for the expected value, what we're going to need to do is find out that value, and we're going to have to take it times the probability. So winning the bid, we know that we're going to end up with $70,000, but remember, we're going to have an initial cost of $14,000. So in other words, we're winning the bid. The amount we're going to be dealing with is $56,000. In other words, 70,000 minus 14,000. But I also know that my probability, so let me go at amount. And so we'll kind of do a chart similar to what we had before. So I'll have the amount, and then I'll have the probability. So the probability on this one would be then 0.2 is what they gave us. Now, if we lose the bid, remember, we're not going to get the $70,000, but we're still out the $14,000. So that really is going to give us a negative $14,000 for losing that bid. So our amount is going to be negative $14,000, but now our probability is not going to be then 20%. It's going to be the opposite, because if you win, you're either going to win or you're going to lose. And so in this case, the probability would be 1 minus 0.2, which would also be then 0.8 is what we'll use. So then for my expected value, I would take then 56,000 times 0.2. And then I'm going to add then, keep in mind I'm going to go a negative 14,000. So you could have actually just gone ahead and said minus 14,000 times 0.8. And when you calculate this out, you're going to end up being, it's going to be then 11,200 minus 11,200, which in other words is going to break even at $0. What this means is that the expected value means that you're going to break even, and so in this case, it doesn't look like it may be worth it. Just go ahead and try to put the bid in because the expected value happens to be 0. Our last problem that we're going to be dealing with is going to be when we're dealing with the game of roulette again. So we're going to find the expected probability of value of a game, multiply the gain or loss for each of the possibility outcomes and its probability, and then add the products. So in this case, the expected probability for betting $1 on on the number 20 in roulette. If the ball lands on that number, you are awarded $35. If you get to keep the $1 you have, and that is that you paid to pay. If the ball lands on the other 30 slots, you're awarded nothing, and the $1 that you bet is going to be collected. So again, if we look at the amount that we're going to put in, so if the ball lands on 20, and so we actually get that money, we know we're going to get the $35. And we're also going to get the probability of that would be 1 out of 38. Now, if the ball doesn't land on 20, then we're going to end up paying a negative $1. In other words, we're paying $1. And then our probability for if it doesn't land on that would be then 37 out of 38. And to find that our expected value, we would take then the 35 times 1 out of 38 plus, remember it's a negative number, so it's a negative $1 times 37 out of 38. And then we'll end up then with, when I look at this, I have 35 over 38. I'll end up with minus 37 out of 38, which results then in a negative $2 out of 38. And that would just simplify to a negative $0.05. And so the expected value is going to be approximately a negative 5 cents, which means in the long run, the player can expect to lose about 5 cents on each game that they're played. So again, this is probably kind of over the long run, and that's where we will use the expected value. All right, thank you guys.